Hey everybody, it's Mr. Canfield. Today we're looking at Chapter 13, the derivatives of inverse functions. I have a little device that I use to remember this, and that is, we call this the Magnum Pi Formula. So we'll talk more about that, but Magnum Pi. It's an old show. I think they rebooted it recently, but P and I stands for private investigator in the show, but here P stands for prime, and then I stands for inverse. And if you remember Magnum Pi, that can help us remember the order that we're going to be using this formula. So basically, you have f of x, right? And then you have its inverse, which we call f inverse x. Then there's something called the reciprocal. The reciprocal is 1 over f of x. I want to let you know, I want to remind you, inverse and reciprocal are not the same thing, even though traditionally this notation indicates reciprocal. I want to remind you that when we see this is called inverse notation. It is not reciprocal notation. One of the worst notational problems we have is that there's two meanings to this. But when you see it like this means inverse. So what's the definition of an inverse? Well, the definition of an inverse, let's say there's some function where we have x comma y. The inverse, so any x comma y, we could say it's a, b. The inverse literally takes x and y. Every x turns into a y, every y turns into an x. So the inverse would look like this, b comma a. So if I know that a function has 2 comma 5, then I know its inverse has 5 comma 2. That's what the definition of an inverse is. So back in the day, you should have done this in pre-calc, or maybe even algebra 2. But I know you do it in pre-calc. We've taken a function, so let's say we take the function. I should just go and see what Stu has in his notes. So he 2, 4, and then 4, 2. All right, so let's see. So if we have a function, f of x is equal to x squared, the way that we would find the inverse of that is we'd swap x and y, and just remember that f of x is a synonym for y, so this is really saying y is equal to x squared. So when we swap it, we get x is equal to y squared, like that, right? So then we solve this for y, and we get y is equal to the square root of x, right, by taking the square root of both sides. But here's the thing. The square root of x, it's not just the square root of x, because when I introduce a square root into a problem like this, the positive square root can turn into x, but so can the negative square root can turn into x. So because of that, this is actually a plus or minus. And the true inverse of x squared is actually the square root of x. But the problem is plus or minus the square root of x looks like this. Here's the positive square root, here's the negative square root. We have some problems. This is not a function anymore. If you remember the vertical line test, where you draw a vertical line, you find out there's more than one y value for a single x value. This is a problematic thing. So we're going from here to here, and you might notice that it's almost just turned on its side. So in reality, it's turned on its side and then flipped around. So oh no, she's fine. So the way that we find the derivative of an inverse, one way we can do it is we can calculate the inverse and then take the derivative of said inverse. So if I said find f inverse,
You're okay.
oh, how do I write the notation? I always forget where the prime goes. maybe it's just find f inverse prime. So the way we do this, so we got that, right? We just say y prime is equal to 1 over 2 root x. And you could even, you know, throw a plus or minus one there saying it's either one. So you have to take the inverse first before you find the derivative. But there is a special formula, and I'm not going to go through the derivation of this formula. I'm trying to make this video lesson pretty short. But the shortcut is, instead, if we want to find the derivative at a specific point, which is what we're normally going to do, we actually can do 1 over f prime of f inverse of x. So we will look at that, but it's interesting for this situation, it does work where you see, so f prime, well, this is f, right? What's f prime? F prime is 2x, right? So this would be 1 over 2x, but instead of x, it's f inverse, and f inverse was square root of x. So this formula holds true, and if this has been a little bit of a whirlwind, don't worry, we'll get into it. So so let's see, here's 4. We're just going to jump straight to example 4. F of x is equal to 2x cubed plus x squared minus 1 at x equals 2. So we're trying to find the derivative of the inverse at x equals 2. So the way that this works is we can use our inverse derivative formula, 1 over prime inverse, right? F prime, f inverse of x. And in this case, it's at x equals 2, right? So it's 1 over f prime, f inverse of 2. So it turns out I don't even need to know what the inverse is if I know what f inverse of 2 is. If I can find out what this is, then I just do 1 over f prime of whatever that number is, and I'm done. And this is the way these problems usually go on the AP exam. So that's why I'm kind of jumping to this. Here's the thing. Trying to find f inverse here is very not doable with what we have and the different techniques that we have. And if you were to look at this, you know, let's try. X is equal to 2y cubed plus 2y squared minus 1. Trying to get y by itself here is a little bit of a fool's errand with if we're trying to get y explicitly in terms of x. So that's not going to work for us. So instead what we can do is we want x equals 2, right? So let's think about this. We know we have f of x and there's f inverse, right? And we talked about this earlier in the video. F of x has 2 comma something, right? Well, if f of x has 2 comma something, then f inverse of x has something comma 2, right? So, you know, I could go in, I could plug 2 in here, that's 8, that's 16, plus 4 is 20, minus 1 is 19, so f of x has 2 comma 19, f inverse of x has 19 comma 2. But I want, what's f inverse of 2? I want 2 comma something here in my inverse. Well, what does that mean? 2 comma something in my inverse means that my original function has something comma 2. And so when I see we want to find the derivative of f of x at x equals 2, I'm really saying when y equals 2, that's the actual number that I'm going to care about. So y is 2, now we have to find x. So 2 is equal to 2x cubed plus x squared minus 1. And I'm not going to mess around here. I'm just going to go straight to my calculator. Because solving this by hand strikes me as something that we can't do right now. If you're trying to solve this by hand by adding 1 to both sides and then dividing by x, you're cheating. Not cheating. You're not doing algebra anymore, or you're introducing problems. That's not how we solve this. We can't solve it like that. Dividing both sides by x brings in numbers that x is not allowed to be, and this stops being an equation that we can work with. So what I'm going to do is I'm going to find out where the left and right side of this equation intersect. So I'm zoomed pretty conveniently. Let me zoom back to standard. Okay, they do only cross once. So I want to find that crossing. On my calculator, I can do this by using the calc feature here. So second calc, and then I can go to my intersect. So it says first curve, and there's the cursor. As long as it's on one of the 2 curves, I can just hit enter. Second curve, I can hit enter again. Guess, so I can actually move the cursor with the left and right arrows closer to the intersection point. Sometimes when there's more than one, this is helpful to do. So 1, 2. Maybe you saw that. I wasn't focusing too much on what the numbers were. I was more thinking about a method to answer it. So we know when x is 1, y is 2 in our original function. That means in our inverse, when x is 2, y is 1. So what we can do, if you remember, this formula says 1 over f prime f inverse of 2. Well, f inverse of 2 is that y value we just got. It's 1. Y or x value we just got. And so now, the derivative of the inverse of this, when x is 2, is the same as 1 over f prime of 1. And f prime of 1 is nice and easy, right? Because f prime is just, what, 6x squared plus 2x, and the 1 goes away. So then we just plug in the 1. 6 plus 2, it's 1/8. This process is identical. It always works like this. So let's talk through the process. What did we do? And it might help to take some notes for yourself. So the first thing we did was we wrote out our formula, and I used Magnum Pi, prime, and then inverse, that order. Then we didn't have to do this part. This was for explanatory purposes. We did have to do this part, though. We knew that since we wanted 2, that was actually the y in our original. So we set y equal to 2 and found x, and then used that in the formula. So this this is one of my kind of weak spots personally. And I really have to organize it visually, or else I get very lost. So we want, for number 5, we want f inverse of, so we want the derivative of the inverse when x is -3. So all I have to do, remember we go xy, sorry, here's my original, so here's my inverse. So my inverse we know has -3 comma something, and to find out that y value, we can use our original, where we know the y value is -3. So we're trying to find the x value here. So what I'm going to do, -3 is equal to e to the 4 minus x minus x. All right. I was like, cool, we're going to be able to solve this by hand. Nope. Nope. It's 1, isn't it? I mean, it's 3. It's 3, isn't it? Stop guessing. Is it 0? No, it's not 0. Okay. All right, enough guessing. So I can do this again. I can think -3 equal to, another way to do this would be add the 3 to both sides, and then there's another function called zeros here. E to the 4 minus x minus x. All right, so if I hit graph here, All right. Oh, it's 4. Oh, silly me. So it intersects when x is 4. Then that means that that's there. And I always go through and do this. I always write the number, write the thing. It really helps me make sure I get the order right on things. So f p I, and then the x value was -3, right? So when x is -3, what was our y value? It was 4. So I want f prime of 4. So now I just have to find f prime and plug in 4 to it. Well, let's see. F prime of x is equal to, remember that the derivative of e to the x is just e to the x, so it just stays the same. But then I'm going to multiply by the derivative of the exponent, which is what, -1? So I'll just call that negative e to the 4 minus x, then minus the derivative of x is 1. Now I'll plug in 4. That's e to the 0. Negative e to the 0 is -1 minus 1. I get -2. So we get -1/2 for our answer here. So looks like for 4 and 5, he was saying those were non-calculator questions because those answers would be, I guess, considered a little bit trivial. But trivial is a pretty pejorative term for me. I'm always just like, how did you guys figure that out so easily? So let's see, number 6, x cubed minus 4x squared plus 7x minus 1 at x equals 1. So same game, right? Here's f inverse. So I know it's 1 comma something. So then that means that's something comma 1. So I'll set this equal to 1. In case you forget the fundamental theorem of algebra, this could potentially have 3 different crossings. Remember that the highest exponent determines the number of zeros that something has. Okay, let's see. Let's see how many crossings we get. 1. Oh, still just 1. Okay. Stu is throwing a softball with these. Cool. All right. So I think this might be the first time I say this in this course. Certainly the first time I've said it in a while, for me at least, because maybe my video is old, and in my old videos I might have said it. But anyway, I go to 3 decimal places. This is not science. This is the AP exam. The AP exam, you go to 3 decimal places. If you don't go to 3 decimal places, you are wrong. If you write 0.3, you're wrong. If you write 0.34, you're wrong. If you write 0.35, you're wrong. If you write 0.349, hooray. If you write more decimal places, you're fine. So go to at least 3 decimal places. So 0.349, 0.349. All right. So you can always go more, but I'm fine doing 0.349 today. And then I just use my formula, right? 1 over f prime inverse. So I know it's 1 over f prime of 0.349. So I just find my derivative, 3x squared minus 8x plus 7. Plug in 0.349. Oh, here's a fun little trick. 0.349. All right, we got that. If you hit this STO button right here, store, I can actually store that as a variable. And so now, like, anytime, like if I typed 2x or 2x plus 1, it'll actually kind of hold on to that. So I can say 3x squared minus 8x plus, I want to make sure I wrote 7 and not 9. Okay. So 1 over 4.573. So I got bacon 0.218. You might be like, Mr. Canfield, you did not round. You are fired. 0.218 is fine. 0.219 is also fine. Since this does round up to 0.219, they accept that. They also accept 0.218. I will accept either one. If that's new to you, the idea is that from a like philosophical standpoint, it's not so 0.218 is a more realistic answer than 0.219, saying, okay, we only made it to 0.218. We did not make it to 0.219. So it's not fair to say that we made it to 0.219. It's more of like we weren't able to complete that 0.219. So it's not fair to say that we made it there. It's a matter of philosophy and preference. Most people you'll run into will prefer to round, and I definitely prefer to round, but I wanted to talk about that. All right, so we're gonna actually skip example 7. 5-10 minutes, hopefully. Oh. All right, so final example. The function, ooh, it's not on my screen. Let's fix that. So we're gonna, oh, okay, then Frappuccino's fine.
So if you want a hot drink, I'll find you something.
Okay, yeah, any of the fun drinks are fine. Mrs. Canfield has her friend coming over, and she's getting a Starbucks. The function f is differentiable for all real numbers. It's still not on my screen, idiot. Okay, here we go. The table to the right gives values of the function and its derivatives at x equals -1 and x equals 4. If f inverse is the inverse function of f, find the equation of the tangent line to the graph of y is equal to the inverse of x at x equals 4. Equation of the tangent line. Remember, that's the derivative equation. Hold on. So this is really just saying the derivative is going to be our slope, right? So equation of a tangent line. This is going to be 1 over f prime, f inverse at x equals 4, right? Oh, then that means this is going to be 4. The cool thing is this formula, well, what's f inverse of 4? So this table is all we need, right? Because we can say, well, here's f inverse. F inverse is 4 comma something. F is something comma 4. Oh, so if f is something comma 4, f is -1 comma 4. That means f inverse is 4 comma -1. So then I can replace this with a -1. And now it's really just asking 1 over f prime of -1. F prime of -1 is -2. And we're done. It is a weird, circuitous thing that we do with this, but this is the main idea. I hope this was helpful. Let me know what I can do moving forward to help you with these problems. Canfield out. Bye.